Welcome to AiPod, AI Sensem's podcast, where you learn all things about AI. Today we are in episode 11. Oh my God, I don't have enough fingers. 10 plus 1. Okay, so today we have got a very interesting topic, and today joining me is our special guest, AI Ray. You guys know him, AI Ray.
Yeah, guys.
So there's AI Ray with us, and today we will be deep diving into RAG. Now, what does that mean? So there are three things we're going to talk about. Number one, we're going to tell you about why we actually need a RAG. Okay, what's the RAG and why you need it? Because of security concerns and data privacy policies. We're going to show you a quick example of a small little RAG that we have made, and then we'll get into the deep dive of RAG. So are you guys excited for today's episode? Let me start by giving a bit of an introduction, as an AI Ray will come in over here very soon, and he'll also be explaining. So AI Ray, we have these two privacy policies of OpenAI and Google Gemini, right? So you remember we discussed this and we told it to our viewers as well, isn't it? So both OpenAI and Google Gemini, in fact, in Google Gemini, they use human reviewers to actually look at your data. And so is that scary?
Vivek, the scary part is that they both comply with GDPR policies, which means they don't retain your data, but then they've got people going through it.
Exactly.
And the worst thing, or probably the best thing for them, is that they're taking your permission to do it.
Correct. So that's where you see a lot of customers are so paranoid that they don't want this because they feel that their internal data can be exposed and it can be used to train the systems. And even though these data might be like masked, etc., some of it might spill out, right? So let's explain to users what is an RAG. It's not a RAG, piece of RAG. It is basically Retrieval-Augmented Generation.
Augmented generation.
Yeah. So that is what a RAG means. And so here we've made a small little prototype so that we can show our viewers. So
that's cool, right?
Yeah. So here's the thing. So we've got different types of data, right? So a good example of a RAG, I always give this example is, so let's say if you have a library and you've got different types of books like fiction, mystery, etc., romance, but you come into this library and you need somebody to tell you where to go, right? Otherwise you keep on searching, isn't it? So a RAG actually is a map towards this library of information. So here are some multiple informations, like you can have the retail audit over here, or you can have a brand health track report, so many reports. You can build a centralized data platform which can ingest all of this information. And you can run a RAG on top of this, which allows you to query into this data, where data will be connected between all these kind of reports, and you can get a very good kind of a result. Okay, so I thought maybe I can show users this example that we've created. So what we did was, if you look here, we've got these 3 BPS publications. This is the Bureau of Statistics in Indonesia. There were 3 reports. Each of them got hundreds and hundreds of pages, and they've got a lot of tables, they've got charts, etc. So what we've done is that we have built a RAG model on top of this information. And here is the information that we can ask. So here is a prototype that we have built, right? It's iSensum IQ. And yes, it's in Bahasa. But you can draw. And now for this episode, we will talk in English. So I put in a question over here, which asks about the socioeconomic conditions in Indonesia, right? And we can just ask this over here. And as you can see, immediately it is accessing the information from those 4 reports, from those 3 reports, and giving you an answer. Okay, this is the example of a RAG that we have built. And so companies can have different disparate sets of data, which we can collate into one unified source, and you can then query this. So imagine you had a chat GPT internally in your organization where you can query and get answers for your reports. Okay, so I'll stop now. It's over to you, AI Ray, and AI Ray is now going to tell us the components inside a RAG. What are the different things? And over to you.
So while I'm sharing my screen, Vivek, I think the little animation you had of that guy cycling and running while the process was going on was quite cool.
Oh yeah.
So
didn't
I
notice
think
that.
people would enjoy running your prototype system as well. All right.
That's
So
true.
coming back to the RAG. So Vivek, that's a very good example you gave about a library with so many different types of books and you having a librarian, so to speak, who will be able to point you in the right direction. Say you're in the mood for fiction, he'll be able to tell you exactly where to go. I think I'll stick to the same example while we are going through this. What you see on the screen now are the various components which comprise, let us say, an enterprise kind of a RAG. In the previous session that I did with you guys, we showed how you can run LLMs locally. And I'm sure if any of our viewers have tried to run it, they would have noticed that there is an option to upload documents and ask queries. And shout out to all the guys who tried it. In case you have missed it, I would encourage you to try it again because that's the best way to start your journey with LLMs and retrieval-augmented generation systems. So we are going to look at this and I'll try and explain it in a very simple manner so all of us can get a hang of what is going on. As a preview, there are 10 steps involved. And the first step when you build a RAG or when you design a RAG is to have a data collection pipeline. And you can see on the screen, there's a lot of different types of digital data which is listed, the various websites, Medium, Substack, LinkedIn, GitHub. And all of them can be inserted into something called an ETL. An ETL is essentially extract, transform, and load system. What it does is it extracts all the information, it transforms it into a manner which can be stored into a local or let us say an online database, and then it will load it for the remaining RAG platform to utilize. And as you can see here, the ETLs they will load this information into a database system such as NoSQL. And all this infrastructure, let me remind everyone again, you already said it, Vivek, all of this infrastructure is in-house. Yes. Even if it is on the cloud, on an AWS or Azure server, it still is clustered only specifically to you. So it's not necessarily going back to, say, ChatGPT or Gemini or any one of those guys.
Yeah. Only thing here, I think we just also need to, the Medium, Substack, LinkedIn, GitHub in this example are the data sources. So for instance, for us, this would be Nielsen, Brand Health Tracker, internal sales, Major, those kind of reports. So that will be your data collection. Yeah.
So you're talking about files, Vivek, and we'll address that also as we go on.
Correct.
And then if you look at the screen let me use my magical laser pointer here. Oh yeah. So if you look at the screen here, the queue. Now the queue is a very small but an essential component because as you load the data, it moves in a stack form, not a stack, a pipe form. It goes from your data source into the next step, which is your feature pipeline. Now, all your data sources have different types of information presented in different formats. You have information in tables, you have information in presentations, text, graphs, images, and so on. And all of them need to be queued up and then accepted or inserted rather into a feature pipeline, which is going to separate all of these features. Now, any of you who are familiar with the NLP process of machine learning, you always take information and then once you have digitized it, you try to extract the features out of it. And then you use those features to carry out something called embedding. But more on that later. Now, once you have extracted all the features, you would want all the information to again be stored in some form of a database, which is not SQL. Now, imagine this. You have a table of attendance in a school, right? So when we all went to school, we had roll numbers, names, and then there was a long table of the days of the month and the teacher would call out the attendance and tick who was present, right? So that is an example of a database system. Simple, structured information where each row will indicate information about one particular type of entity. Now, once you've extracted all this information, you want to put that into a vector database because a vector database has the ability to link information with several different plots. We'll talk about this again, I think, in detail a little later. Now, in the vector database, once all the information is again loaded, it's ready for a retrieval client to work on it. Now, remember, this was the first half of the process where we've been able to insert all the data, process it, and bring it into a vector form. And here onwards, the extraction or rather the retrieval of information will start, right? So as you move to the left of the screen from here, from vector retrieval clients, and follow this arrow, now we are looking at a client system which is similar to the LM Studio which we demonstrated to you earlier, where there would be a retrieval client which would be working in the background to pick up all the information that is required and then turn that into a prompt layer. Now, prompts are our interface with all these LLM models. You have to type in your query to get an answer, or rather, talk to it in case you're using Whisper. So once the information has been given to the prompt layer, that is where the LLM fine-tuning begins. And that, my friends, is the training pipeline. You have to train your system to understand your information so that it can address your queries better. Remember, all the models out there, they're very good at conversations. They're very good at understanding what you're saying to them, but they're not so good at finding the information that you need. That is where you need to be able to train the LLM. And that's what is happening here. You fine tune the LLM, make it understand what you're doing, and then you can run an experiment tracker, which is tracking the performance of the responses that your LLM is generating. And then there's a cute little box here saying LLM candidate. Now you see, one of the most important things when you are running a training on your own data set or training your LLM is to be able to choose the right model for the right job. And that is where when you go on the internet and you try to look for various kinds of models, you'll find very different options. There's something called Instruct, then you'll have Snell, you'll have, when it comes to vision, you've got Snell, Dev, and Pro models. When it comes to text responses, that is the chatbots, you have something called Instruct and Base models. While all the models are specific to certain tasks, but then the LLM itself, once it is trained, you need to be able to choose which is the LLM which is going to respond to your queries best and which is the one which will perform well for your requirement. Now here, you can maintain something called a model registry, and based on the queries and based on their responses, you will decide which model are you going to use at a particular point in time. For example, now all of us are familiar with Llama 3.1 or 3.2, which is a general purpose model. Now, initially we had dedicated models for text generation and separate models for vision, such as Flux and so on. Now we have the multimodal options available with all these models. So the same model can be used for having conversations, and it can also be used to generate images, which is a pretty cool thing. But then it gives you an option to choose what is the right kind of a model which will suit your requirements, right? So from here, you run the training and then you test it on different LLMs, different models. And once you've done that, you will choose the LLM which performs the best for you. Of course, the metrics and parameters for choosing the accepted LLM will be different for each company. Now, once you have loaded a quantized LLM, that's a interesting word there, Vivek, quantized. Now, what happens is the models which are available, I encourage everyone to just Google Llama 3.2 and you'll be taken to the Meta website, which has the descriptions and the details of all the models. You'll notice that there's something called Llama 8-bit, there's now 8 billion parameter, 11 billion parameter, 90 billion parameter models. Now, these models generally indicate how many different parameters have been used for training them. In a very simplistic way, I think that's the best way to say it. But then, you don't need the whole world's information if you want a model which is just going to look specifically at your marketing and financial reports. Right. So you need to compress that model. You need to reduce its size, increase its usability. And that is the process known as quantization. And it's a very boring mathematical process, Vivek, so I don't think you should cover that in your podcast.
Basically, you just need to think of it as model size reduction. It's like zipping an LLM. You zip the LLM into a smaller size. That's basically what quantization means.
So then once you loaded your identified quantized LLM, you can run it in parallel on a twin LLM, and then on the right, step 9 is where you're receiving the queries and you're posting responses. So that's on top is the query, and then you generated a post Now, this is done through something called a REST API. I think everyone who's watching this would be aware. This is basically get post kind of a response which you can generate on various Node.js or HTML or anything else. This is your Postman, Vivek.
Yeah.
And from here, you have the retrieval clients. Remember, we spoke about the retrieval clients running on the Quadrant database, on your vector database. And then once your vector database has provided the necessary embeddings, then it will generate the text and information and send it out as a prompt. Now, the loop that you see here, while this is the part which is there for the user, this is for your own internal IT and development teams to carry out prompt monitoring, evaluate the LLM candidates, and then, if required, change it up so that you can serve a different model or a different LLM based on the requirement that's coming out. So that's the whole flow, Vivek.
Yeah, it makes.
And let us hand over the screen back to you.
Yeah, I think maybe we can just go through this quick. So, like a summary. Yes, it was a bit technical, guys, but that's the whole point, right? This is not easy stuff, but I'm sure people will actually understand this. So, if you look here, there were these components. There are 10 components in a RAG system. And also, just to shout out to the guys from MIT who actually gave this diagram. It's there on the GitHub. We'll post the link in the bio, guys, so you can also go and watch it out. They in fact have a training program as well on this. And I thought their block diagram was the best, which is why we use this model, right? There are these pipelines. So we've got the data collection. So we will have our clients put in the data, correct? We put in our data, the reports. It can be PDF files. It can be Excel files. It can be Word documents. It can be whatever file that you want, right? But then you have an ETL method so that you can extract the information. But the most important is the steps number 2 and 3, where you have this feature pipeline so that you can create the correct context, which then is put into the vector database, which is the point number 4. So now you have a context and the data with it. Okay, so that is, I feel, very important, isn't it, AI Ray, right? That you created context and data, because that's the starting of the RAG has started over here, isn't it? This is where you would have just dumped this on the ChatGPT and you try it, guys. You'll get nothing when you ask the question, because you see what is important is this part of creating this vector databases and all that. The other parts are the training as well as the inference pipeline, which I think AI Ray has explained very well. But you can see these components in number 2, 3, and 4 are very crucial for ensuring that the map of the library has been created, right? And in our next episode, guys, we're going to get in deeper into like the RAG, and we'll tell you why perhaps you should be choosing perhaps pros to develop a RAG system. So
absolutely.
Yeah. So any final thoughts, Ian, on RAG?
Yeah, Vivek, like you said, let's discuss the detailed part on the other side, because I'm sure that right now this looks so easy that you can just run the whole chart and things will be running like this. But let's learn a little more about it to understand the challenges.
Deceptive viewers. Well,
absolutely.
Thank you very much. That's it for episode 11. Please put in your comments and put your likes and shares. Of course, do share it to all your people. And we also look forward to hearing from you as to what else would you like to hear. That's it, guys. Signing off. AI Ray signing off as well. Thank you, guys. Bye.
Bye, guys.